Hey kiddos, two more improper integrals today because they're going to look a little bit different than yesterday. So if you remember yesterday, you could recognize an improper integral because you had a bound that went to infinity. Today, you're going to have troublesome bounds, but you're going to have to recognize that they're troublesome. They're not going to be obvious. So my bounds for this question are going to be -10 to -3. Everything looks fine and nice and simple, but if you investigate a little bit, you've got problems because what this question is asking you to do is to accumulate area starting at -10 and stopping when you get to -3 for this function. The trouble is, this function does not exist at x equals -3. So I can't accumulate area somewhere I don't exist. So here's what we do. Same thing we did yesterday. We're not going to equal that value. We're not going to equal infinity. We're not going to equal this troublesome value of -3. We're going to approach it. So we're going to have the exact same setup. This is -10 to t, and then the exact same stuff on the inside. And that's, honestly, if you stop the video right now, you'll be fine because it's just taking an integral, evaluating, and taking limits, just like yesterday. It's just the setup of the limit. Oh, wait, I hope you didn't stop the video because there's one other thing. So the only difference between these and your infinity limits is we're going to give this a direction. So if I start at -10 and I stop at -3, and I don't actually want to equal -3, I'm going to stop just to the left of -3 because it's my upper bound. So whatever this function looks like, well, I guess I should at least make it negative. If I start at -10, I don't need to make it all the way to -3. I just need to make it to the other side, the left side of -3. So that's why we're going to go -3 on the left. Okay, everything else is the same. I want to challenge you to not do a u sub for this question. So the -1's not scary. We can pull that outside of the integral, and I'm going to. And then think of this as x plus 3 to the -2/3. It is not a natural log. Oh my gosh, don't start doing that. It's not linear, so it's not a natural log. This is a power rule. So we're going to have a limit, because you haven't taken it yet. T goes to 3 on the left. I guess I'm not going to pull that out of the integral because I'm just going to take the integral. I'm going to add 1 and divide by the new. When I add 1, I get x plus 3 to the 1/3. When I divide by the new, I'm going to be dividing by 1/3. That's the same as multiplying by 3. And I don't want to lose this negative, so -3. Evaluated from -10 until t. All right, plug in top, minus plug in bottom. This will be the limit. So when I plug in top, I get t plus 3. Minus negative makes plus 3, -7 to the 1/3. Just like yesterday, this is the piece we care about because this is not affected by t. So if we look at what's going on in here, oh, I lost my negative on my 3. Why didn't you tell me? -3, -3. So if I put a -3 in for t, it's -3 plus 3. This is going to 0. So this limit converges to a value of 3 times -7 to the 1/3. Strange value. That's fine. Doesn't matter. Let's do another. So these integrals, the integrals themselves can be anything. Like they might have you do a by parts inside of here. That's fine. I can do by parts. I can do u sub. I can do all kinds of crazies. But it's the bounds that make them improper integrals. So for this question, the lower bound is the problem because our integrand function does not exist at 4. So how could I possibly accumulate area there? So what we'll do is we'll take a limit as t goes to 4. This time we're going to be to the right of 4. Since we're going from 4 to 10, I'm going to start on the right-hand side of 4 and then go all the way to 10. I will pull out my 9 because I thought to do it this time. I didn't think to do it last time. -9. And actually, let me rewrite this while I'm doing all that. Let's think of this as x minus 4 to the negative 4. And now our bounds are t to 10. It's not a u sub, so I don't have to change my bounds. I'm just sneaking up on one of my bounds. Okay, you always have to write limit because it's the last thing you do, so you're still writing limit. If I add 1, divide by the new here, then I've got x minus 4 to the negative 3 divided by negative 3, remembering that there's a negative 9, makes it 3. And then we're going to plug in from t to 10. So this will be limit t to 4 on the right. I'm going to have 3 times 6 to the negative 3 minus 3 times t minus 4 to the negative 3. And let's go talk about this limit. So good. Oh, look, 4 minus 4 again. That must be 0. No, it's not, because it's being raised to the negative 3. So this time it's going to be 0 to the negative 3. Remember, a negative reciprocates. This is 1 over 0. This is actually going to infinity. So I have a number minus infinity. This thing diverges. It does not approach a value. It approaches an infinity. So we just say diverges, and we're done. That's it. Told you it wouldn't be so bad. Let me know if you need anything.